Okay. Da-na-na-na.
Switch statements, because this is what I read about today. So I was wondering which implementations exist and like pros and cons for. I can talk a little about the approaches that I read about today, but I just love to hear.
Okay, wait, yeah, fine. We're live and people are piling in here. And I am doing maintenance for folks as they come in. And we're just taking a second to catch up. And then, you know, I can go first, but anyone can talk if they want here. Okay. Justin is just not going to join properly. He's going to fail out. Okay. So there's a minimum quorum here. There's probably more people going to show up. Standard spiel. You're live. We're recording. I'll put it up on Twitter and YouTube within an hour or two afterwards. Open mic, ask questions. You know, I reserve the right to moderate, never had to do it. Conversation goes where it goes. Ophir, is that the right pronunciation? Has a question about switch statements. You want to ask it again? And then I'll probably still add people over the next 5 minutes, but then we'll go.
Sure, I can give a little background. I just mentioned I'm probably the only one here who hasn't written compilers in the past. I'm just reading about it now for the first time. I have a security background, not very much of a development background. And today I read a little bit about switch statements and how they're translated into intermediate representation. And I read about two approaches. One in which all the cases appear first, and then there's the test, and the other one in which these things are ordered differently. So I was just wondering if you guys got to implement this type of translation. What are the pros and cons?
So I heard two different things you said that take the conversation different directions. One is there's a language level discussion about what is the semantics for a switch. And one's an implementation discussion. How do you actually get the code out that does the thing? Are you interested in either one of those in particular?
I'm more interested about the translation into IR and not the semantics.
So everyone who you do a compiler, you have to have a translation from basic if statements to control execution flow. And a switch can be modeled as a series of if statements. So that's the first easy answer. It's just a big pile of if statements, and you can manually do that, and you can have the compiler IR internally do it, and there's a lot of varieties. That being said, large switch statements switching over small integers is a common theme in parsers, and the first thing a big compiler does is compile itself, so you always optimize that. And that can be done with a table. And so that's you know, get the basic value into a register, add some sort of offset, load a code value from a table. So you do an array lookup, basically, based on the small integer, and you get a code pointer and you jump to it. So the jump to a code pointer is not a common high-level semantic. It's kind of sort of like doing a tail call recursion optimization, but not really. So there's no easy translation from that to what you see in most high-level languages. It's like going to a label. After that, people do optimizations on switches according to whatever they see. C2 long ago went down a fairly aggressive path. So there's a profiling of the data available. Many arms of switches are much hotter than other arms. That's kind of common. It's rare that it's an even smear. It's usually very spiky. So you do a classic sort of histogram-based breakdown, doing tests on the common cases first, maybe doing a binary search based on the frequencies. If you have big gaps in the tables, you might do table lookup at where you have dense sections of table and have if statements to switch between the table branches. C2 does a tiered thing where he does common cases and gaps around and bottoms out at leaf tables if it's even, and if it's not an even, if it's a very uneven distribution, he'll break it out in more ifs. Different people do different things depending on how aggressive you want to get, but the first easy cut is you do a bunch of ifs in a row. That's the obvious.
So this is why Python doesn't have a switch case statement, I guess, because
no, Python has a different story here. So Python doesn't have a machine code generator under the hood. He's all interpreted. So when you look at a switch in Python, and that's a different question. So when you look at a switch in a language, whether it's in there or out of there or how it looks is up to the language designer. It has nothing to do with code generation at all. So the language designer decides they want to have a switch or they don't. So C wanted to have a switch. There was an obvious need for it in terms of parsers and parser generators. There's an obvious close to the hardware execution. So there's a fast way to do it. So C picked up switch statements a long time ago. Other languages, more modern ones, typically begin to replace switches with sort of a structured pattern matching, which is a little more useful, a little easier to read, get the same kind of job done. That's a language design choice. So I don't know why the Python guys decided they wanted a switch or didn't. If they wanted to have a switch, there'd be a fairly straightforward translation in an interpreter even to how you implement it. But I have a switch or I don't, that's a language design choice. So, you know.
I think I have one more question. I got to reverse engineer in the past a little bit and saw how cases are translated into indexes in a table where you have pointers for the code for the statements, the corresponding statements. But what happens when the values are not small enough to be indexes into that table? Like what happens if we switch on very large integers, for example? How does a compiler translate those into indexes? Do you understand my question?
Yeah, I do. So you don't. So, okay, so you play the obvious games of scale, offset, bias, which I think I've only ever seen people do bias here. If you have a range of values and they start at 2 billion and go to 2 billion and 10, then you subtract 2 billion, you get 0 to 10. Other than that, you don't. You do an if statement. So there's a couple different varieties of that. One is you just say if you have 10 elements, they're random numbers between 1 and a million. You do if 10 ifs in a row and you're done. I've seen it done with binary search. I've seen it done with a table of values that you're switching on and a table of entries you're going to jump to. And you have a table loop that says for I equals length of table, compare element to value. And if I get a hit, jump. So a couple different ways to translate there. And all of them you can do in a high-level language. So how would you do the same behavior in a high-level language? Right? Once you got a translation from a high-level language, and the translation uses sort of not the switch statement, but it uses other things that are pretty common, then those common things have an implementation. And there you go. That's what the compiler is going to do. I'm not saying that's what it has to do, but there is a way forward. And lowering switch. There you go. So in the chat just got some links on switch lowering improvements. Yeah. So kind of the fun, for me, one of the fun things about compilers and compiler IRs and doing this kind of stuff is the optimizer's job is to take something complicated and lower it down to machine code and clean up all the extra crap. And that's what it does, and it's very good at it. So if you have a complicated high-level semantic thing like a switch, it totally suffices to in the parser for the switch, unroll it to a pile of ifs and then walk away. And even if that looks highly inefficient, it is the optimizer's job to make that work as if you wrote a pile of ifs. And generally they'll do a good job. They'll straighten them out. They'll do the binary search thing. They'll reorder the ifs, whatever the semantics make sense to do. And you'll get a decent answer out. So it's kind of a fun game. All of these, I have a complicated high-level semantic, but I can express it. It's basically syntactic sugar. Roll it down to a low level, whether you do it in the parser, or you do it in the IR, or you do it manually, and optimizer takes away. I didn't actually realize that Python doesn't have a switch until you pointed that out. And now that you've said that, I recall, yeah, I've never used a switch in Python, but I didn't never make that connection. And I don't know why they don't have a switch.
They never.
You have an answer on the chat, actually.
Yeah, well,
Oh, why? Why it's on the chat? Yeah, that's a why answer. Thank you, Brandon.
Yeah, they never actually explain it. They tell you all the ways you can work around it. There are some who argue that switches are difficult to debug. Nah. And that's how a lot of things come out in Python, though, is somebody had a deeply held opinion that they just didn't like it. I mean, just like Guido argued forever that tail recursion should not be included as an optimization. And no one could understand why he was so dead set against it, but he was.
God, really?
And
is this like just to make recursion painful? Don't do recursion, it's bad. And so I'm going to make it painful.
Yeah.
I don't know.
There's not a great answer there in that link.
Makes it easier to have Stack Overflow if you don't do tail call recursion.
Oh, is that Cameron?
Yes.
You're very quiet.
I said it makes it easier to detect Stack Overflow if you don't have the tail call optimization.
I would have said, I don't care. But for Java, I had to do perfect Stack Overflow detection. You only ever take a Stack Overflow exception at a safe point, and it happens every time, and there's no crash, and there's no escaping it, and tail calls had nothing to do with that. They would not have made any change. They would have fewer Stack Overflows, but never changed the implementation or semantic or the difficulty of doing a perfect Stack Overflow catch. Totally unrelated.
I guess that's what's the joke, that if you have these optimizations, you'll have less Stack Overflow exceptions, and it will be harder to detect the problem.
Correct. I meant to say /s at the end of my comment.
God. So I'm writing this AA language. Like, here's the implementation of a for loop, and if you look carefully, it implements tail recursion right at the end there. It just says it's a for takes a predicate and a body. It's a function, curried function, and executes the predicate till it's false, so the body till it's true, and then runs for as the last thing it does with pred and body again. That's a tail call optimization. I am totally counting on tail call optimization to make loops. And I don't know. I'm all for tail call optimization.
Going back to the switch. I don't think. Go ahead, Max.
One of you at a time.
There is a Python PEP for a match statement that does sort of more complicated stuff than a normal switch does, but I don't think there's very much two camps there, where someone says, oh, this is nice because we don't have switch. The other camp says, this is the kind of ugly thing we didn't want in Python for X, Y, Z reasons. So this is why Python doesn't get things.
Wait. Say that again. I'm sorry. I was watching. I was doing maintenance and I missed. Say that again, please.
There's a PEP for structural pattern matching that I'll paste in the chat. Oops, that's not what I pasted.
That looks like a popular discussion right there. Yeah. Okay.
Yeah, some people are like, oh, we need this because we don't have switch, and also other languages have pattern matching, and it would be cool if we have that. And then there's another group of people that says this is sort of very not Pythonic, and it's very not obvious from the syntax how to do X, Y, Z. Also, it adds a bunch of syntax. And then they're going to argue about it for probably months or years, and then it'll never get added.
Yeah, Python's a mature language, so all discussions run forever. Hey, Max, I have once again forgotten your email to Zoom link. Can you just private chat me your email, please?
Yeah, sure.
I don't like calling it, sorry. I don't like calling it an optimization when it's actually a language feature. So Scheme, for example, has proper tail calls as a language feature, which means you can depend on it and you can do things that you couldn't do if the compiler just on a whim implemented the optimization. I think that's an important distinction. And
I'm intending to have a full implementation of tail call guaranteed.
Yeah.
So that you can exactly do that. The only mystery thing you get out of it is you get funny stack trace discussions. When an exception blows, how much of the folded tail call do you include in a stack trace?
So what I did was in a previous implementation years ago is I just kept a counter and then assumed it was the same line on each one. So you just put an X, 17 after that line.
Yeah, that's fair. I've gone back and forth on bothering with a counter or not. I think it's cheap enough these days just to include it. every trip around the loop has an extra counter.
Yeah, I mean, it's not that hard actually to implement tail call optimization in Java, for example.
Right. Oh God. I got hammered for years for not implementing it. Like I was in 2 weeks of having it implemented and other things kept coming up and then I left and no one did it forever and a day. And like ever since I got hammered, why did you do tail call while you were at Sun? I was like, dude.
C2 can do it, right?
Oh, absolutely. Absolutely. In fact, there were IR chunks in there just specifically for tail call. Like there's a call and there's a return opcode, and then there's a jump. And that is exactly the tail call optimization. And in fact, things very similar to tail calls are happening with exception flows.
Wait, when we say can, do you mean that it does it right now? I don't think so.
No, it does not do it right now.
Yeah,
I started down the path of full implementation. I put in bits and pieces. There are places where it does tail call like things, but you don't get the guarantee and you don't necessarily get it where you want it. Specifically, it does show up around exception throw and catches. If you've inlined a throw and a catch across different compilation boundaries, he totally does a thing that's basically a go-to. But he doesn't do the right full-blown tail call optimization you need to let you get the guarantee, and that was just a work in progress, and then shit kept showing up, and then I walked. So.
But and what we're going to do with the VM state for possible deal?
So the only thing you need out of the VM state is a bytecode and stack frame execution point that you're going to get back to. You can have sort of missing stack frames in the sense that I can't unwind through calls. So that was the trick, which we had to go get enough convincing people, and I was just going to do it and let people, this is one of these ask forgiveness, not permission. Your stack traces would skip frames.
Okay, for stack traces, when you throw an exception,
yeah,
I understand that. But what if we have a possible DOP where we need to get interpreter frames? We will need to somehow.
Those frames don't exist anymore, though. Once you've taken the tail branch, the frames get compressed to 0.
Yeah.
So so basically, what you're doing is you've got the old frame, and normally you'd put the new frame on top of it, but you analyze the instruction flow so you know that there's no. So basically, what you're trying to prove is there can't be an exception handler still active in the frame that you're leaving. So no guard is active, and there are no must-do instructions after the call, other than return, in other words. So basically, you can just slide the new frame over the old frame, and then the return from the new frame actually doesn't go via the previous frame. It actually goes back to the caller of the previous frame, which may be the caller of the caller of the caller of the caller.
Yeah, I understand how the optimization works, but let's say we have, let's say we need to deauth because some assumption was invalidated, and we had some call in this recursive function, which when we return from this call, now we need to deauth because our code is no longer correct. So in this case, we would need to assemble interpreter frames to model the execution to the point where we
So we're missing a piece here, and that's the tail call is only applicable when the code that follows the return from the call can be moved prior to the call, including the return itself that follows the call. So you have a call followed by a return. And the frame that you would put up in the interpreter would basically say, I just came back from an invoke, and now I'm going to do a return. But that's the only thing I'm going to do is a return, right?
Okay. So essentially, there are no side effects, so you can unwind to an earlier.
Yes, there have to be no side effects.
Okay.
That's what tail call means. It's the tail position. There are nothing after it.
Okay. This fact also implies that we can reuse the interpreter state. Okay.
Yeah. Yeah, I won't say reuse, but I'm with Cameron here. That frame is gone. But instead of returning to this frame that you're removing, and all that frame would do is one bytecode, which is return, you just pre-execute the return, if you will. From the Java semantics, it's no difference. if you were to demand the ability to debug single-step bytecodes at the return point where you have stopped and unpacked and repacked the stack, you would witness that you didn't see those returns in the debugger. If I don't give you a safe point choice, then I can say, and it works just great, but you can't witness because I never let you see it. And that's the semantics you get. It's a standard as if compiler semantics.
Oh yeah, actually another way to get the situation which I was describing is to have a safe point at which you can have a DOP possibly. So you cannot have a safe point there either.
Yes, that's correct. Well, yeah, you're right. There's no safe point there even. Yeah, because there's a call, which is itself a safe point going down. And after this call, there's a return right behind it. There's no safe point between the call and the return. So the call goes down, the call goes down, call goes down. You stop way down here, repacked. Semantically, when you continue execution, you're going to return with no safe points. So there's no witness possible.
Mm-hmm.
Yeah, some optimizations can be just implemented as a go-to to the first instruction of the frame. In other words, the return doesn't actually.
Oh, yeah. Well, that's the loop thing. I mean, that's the whole point.
Right. Because you're not saving the stack for the return.
Yeah.
So as long as locals are properly initialized, then basically the call becomes a go-to.
Yes, and that is, in fact, that is exactly the point. Now you'd like to then have that go-to and all in-between guys be in the same compilation unit, turn into a freaking loop and do the loop thing. But the point of the tail call optimization guarantee is that if it's too big for the optimizer to swallow in one go, you still get the no stack consumption guarantee.
And as a complete aside, Cliff, we implemented the string of comparisons and love it.
Oh, good. Yeah, I saw it. I saw you send me the link. It looks good. Yeah. I'm currently getting my REPL live. So strongly typed partial programs, and you can keep incrementally add partial programs, which is what REPL is. And it's mostly there now. It's getting really close. But I think I'll have a REPL up and running by next week, and that'll be fun. I'm sort of itchy to go after writing larger chunks of code now, and it's getting close.
Cool.
I got a raise. We had that discussion. Whatever, the arrays are in, loops are in. I don't have.
I misheard you. I thought you said you got a raise, and I was like, "Who's paying you?"
Exactly. Well, I've had kind of a massive raise this year, so I'm doing okay. The markets love me, and also Azul Systems paid out. That was the worked at them for a decade ago. So 10 years of nothing. I thought it was kind of a done deal. I got mystery mailbox money. Hey, Cliff, you want some money? And it was a pretty good payout, so I'm okay. I got a hell of a tax bill this year, but I'm okay. Bit tests, yes. Yeah. The more switch. Okay, this is switch lowering improvements. Oh, I don't want to look at a video right now. What are people doing recently on switch lowering? Like, I thought the technology I talked about switch lowering was like 20-year-old shit. 30. It was old when I knew it. Now I have to go look. Fine.
It kind of reminds me of the discussion we had a while ago about
Feedback.
optimizing interface call sites in hot loops.
Yeah.
And they become highly megamorphic. And I was thinking, couldn't you do something like basically a switch where you look at the class pointer and then you have an inline version of the target there, but
C2 does something almost like that. It's close.
But you don't want to do the linear search, right? You want to do basically a jump. So, but to be able to do that, you need kind of the thing you're jumping to be dense.
Yeah.
So you don't need a giant table. I'm thinking maybe you could do some kind of hash sort of thing that's from a sparse set of values, but you know them in advance. you can compute some kind of function or create some kind of function to create a dense set of indexes into some kind of jump table. So you don't have to do linear search. But I was thinking maybe computing the hash would take longer than actually doing the linear search. But I don't know, maybe somebody else has.
So what you can do instead is keep track of which types you search for, and basically you hotspot it. So you say, okay, I've had to do a search on this particular type a whole bunch of times, so I'm going to normalize that type. And what that means is you create a offset-based jump table for that type, and everything that ever asks for that type, you then materialize that V table for that particular type. So now it requires fat pointers, but so basically instead of having so you keep a pointer to the structure and a pointer to the V table as the fat pointer, and now it becomes a one conditional just to verify you've got the right pointer type, and then a jump.
So I think
I implemented that for Graal. I had like 2 iterations of the implementation. The first one, I had a hash function generation based on a paper, like evaluating multiple alternatives for functions. And then I actually evolved to something simpler. I found out that it's easy to find a prime number. So you can have like the profile types that you can dispatch, right? And you have the pointers. And you can find a prime number where you can multiply by the prime number and then do an AND of the bits. And then you can easily have like a compressed table of the targets. And I implemented that for Graal. It's not open source yet, it's internal.
It's like a perfect hash function. So what I hear people say here is
there's conflicts, right? And I have to always check if there's like an unknown key. So there is no conflicts within the keys that I know that are the profile types, but it's possible that a new key, a new type show up, and I have to de-optimize if that happens.
Right. So you still have to do a test in the end. Yeah, so I hear a lot of people saying, you know, what you guys are mentioning here is all basically a perfect hash function. How do you condense a set of disparate values down into a small, dense integer set, and that's a perfect hash function, which is what I heard you say, Flavio, except I hadn't heard this technique before, multiply by prime and AND. That sounds cheap. And
yeah, it's super cheap. I actually, there's a pull request on upstream Graal. I think it's merged actually for lowering switches using that technique.
Interesting. I think, Cameron, what you were talking about is more of an inline cache, right? Where you would just have one inline, basically, implementation, and you have one guard. I was thinking about a case where you have like 20 implementations that you might need to dispatch to.
Right. So basically, we have to have fat pointers anyway. So we already have them. We already have to pay that cost because the reference carries the type, not the class. So VTable carries, the structure, the VTable approach is where the first pointer in the structure is a pointer to the VTable. So that's your class, right? So all you need is a pointer to the struct because that gives you the class via one additional dereference. But since our pointers have to carry their own type, and you could have 10 different types for the same object. It already has to carry that. So basically, instead of having the one check where you're checking, are you the type I think you're going to be that I'm already optimized for megamorphically? Instead, the type pointer can be a pointer to a VTable for that particular type, meaning you know that you need the sixth thing from that VTable. So it basically becomes as fast as a C++ virtual call, but it's megamorphic.
So C2 will inline at least two things with a bailout if there's a third to handle the commonest case of I have two different hot choices at a megamorphic call site and a possibility for more. And that was just to do direct byte buffers versus heap byte buffers. All the hot and IO code all had two options they went to. You could go more, but there's definitely a gain to be had by inlining options because all the invariance of each of the inline choices gets hoisted out of the loop. But you can't do 20 or you get iCache blowout. Somewhere you have to cut it off and say, I'm doing a call. So a lot of things that we looked at that never happened, you could imagine, include vtables for known subsets at known call sites. It's kind of what Flavia was talking about, but we didn't get so clever. Another one was a lot of highly megamorphic function calls and highly megamorphic bushy classes load small constants as a function call. So they're calling to pull up a string or to pull up a true false Boolean or whatever, and inline those more or less into the vtable as constant values that you could load from a vtable as opposed to a function pointer to go execute, where all that function will do is load a constant and return it. There's stacks of things here to be done. Handle the new world order of everything's megamorphic.
But I think the thing we were talking about last time wasn't, it was the linear search for through the interface table, and then you get the vtable of your interface, and then you can do the dispatch, right? The linear search was costing if you have like 20 interfaces.
The implementation that C2 ran with 20 years ago was a linear scan through a table. So if you had 20 interfaces, you touched 20 things. They're, x86 is pretty good at that. So it's 1 clock per touch, but that's 20 clocks just to find the right dude. And then presumably an interface call or a registering direct call, which is probably a total pipeline flush. So it's another 30 clocks, maybe a couple indirect loads to get to the right call. So suddenly you're 50, 70 clocks to do an interface call. It's stacking up.
And it's even worse now because it does the linear search twice now.
Why does it do it twice?
It's a security issue. And I think a couple of years ago it became twice. So the linear search is done twice now.
I'd claim that security folks should get smacked around. We can all break through everyone's security by doing any one of these hardware peak, Spectre meltdowns. What the hell do we care what the rest of it for? Why Python? Was there another different comment about why Python doesn't have a switch, or we think it's all just somebody's mad at switches?
I have another question. I don't know if it's a good point to introduce it. It relates to
no, it's fine. There's a pause in conversation, so do it.
Yeah, I was wondering about Scala and its pattern matching, which is very similar to Switch. And I'm wondering what need to happen in Java to have a similar mechanism.
There's a giant JEP in progress on this kind of thing.
Okay.
It's the called Amber, and if you have a couple years, you can read through the mailing list.
It's ugly.
It's not
I've talked to
ugly.
people I know about it, and they're like, mostly it's like insane and stop now before you get any behind her. You're getting behind and stop before you get behind her.
No, I mean, so Brian Getz is a very good steward for a mature language. So he's slow walking at home, but he's really good at walking things home. So it'll come and it'll be good.
All right, fine.
For me, it's even worse because I also get the internal email list as well. So I have to do double the reading.
I will neither confirm nor deny that I get the internal emails as well.
Yeah, I'm fairly certain I could get them if I wanted them, and I don't. So I'm all good.
Where does the complexity comes from? Why is it so complex to do?
The complexity comes from Remy. Why? No, I mean there's a guy who's very okay. Yeah. No, it comes from nulls. The type system's broken, so there's no good answer for a lot of questions, so they look for the answer that's going to screw the least people, and that's hard work. That's really hard work.
Yeah.
But they do a really good job. So I mean, I'm making fun of it, but they're brilliantly good at this. I'm glad they're doing it.
All right. I always laughed that Scala was the C++ of Java, and Java's
I thought that was my line.
catching up fast.
Yeah, so basically one of the problems as well, because I've been at some of the meetings, but not recently, but right, pattern matching, there's two kind of features in there. One is the conditional pattern match. So you say if X is equal to this pattern, we extract the variables, but that's kind of a conditional pattern, if you will. So you have it inside an if statement. There's also total patterns, which is basically a deconstructor call, where you don't have an if. You just say, I have 3 variables here, and I have one object here that I want to split out into the 3 variables. And a lot of the discussion is around trying to disentangle those two, and you have to figure out how to do multiple returns as well and figure out syntax for that, or should we just use records, and for the conditional return, should we just use optional, or should we use some other runtime internal class to do that? So there's lots of discussion going around that. It's a really big feature.
Yeah, and Brian's had his eye on deconstructors for years now, so he can see the light at the end of the tunnel.
I'm all for a well thought out deconstructor kind of pattern match. I have used them in several different languages, and they're very nice. So, oh, and this particular link that showed up, it has we're going to get rid of the 3 mentions of a class. If you want to type class somebody, you have to say if obj instance of foo, then foo of x is equal to cast foo of obj. And so you say foo 3 times in a row. And it's just like, really? Is it necessary? So fine. So that's maybe going to get fixed. That'll be nice. That will be nice.
I think that one's already in.
Is it?
Yeah, I think that one's already in.
Was created, updated. Well, the last update was just a month ago, release 15.
Yeah, so I think it's final in 16.
Interesting. I haven't jumped off of 8, but this might make me do it.
Yeah. This
modules. I was just like, what the fuck modules for?
They're to make Mark's life easier.
Don't most incantations require you say them 3 times in a row in a mirror?
Don't even go there. No, so use like Elm and Haskell, shit like that, and like no, they do type inference like legit. It doesn't have to be faked. Yeah, and they do a good job here. Oh, but they're adding a freaking variable name. What? That was not necessary.
Well, it's because you can use that variable within the scope.
Well, right.
So
as soon as you
by having a type associated with that variable, you can still change the original variable without invalidating the previous instance of operation. So you're like, if O is instance of string S, now that S has the copy of the reference to the string as a type string. So if someone changes O or changes S, neither one, it's like it doesn't affect the other.
I'm still unclear on the code where I then change O in a way that invalidates.
It doesn't invalidate S because S stays the same. That's
no, I understand why you have S. I'm saying get rid of the S. After you've passed the test, you have a new scope. In this scope, O is known to be casted to a string, and it's therefore string-like throughout that scope. When you
until it
scope,
changes.
I'm sorry?
Until it changes.
Yeah, right. Until somebody overwrites O.
Right.
So you're just saying there's a free extra excuse to put a new variable here, which has the cast value, so that I can go ahead and change O.
It was easier to implement.
Changing S, but that's just I just wrote it into another variable. I don't. Okay, fine. I don't see why you need the syntax here. I'm looking at what I would do differently. How would I rewrite something like show me a sample expression where having the extra variable saved you writing any significant piece of text?
I won't defend that decision, sorry.
See, somebody needs to attack all these great ideas, or the language will just accrete. Maybe Brian's doing a good job here. I don't know. It could be, and maybe he'll come and like smack people around and say, "Okay, this is why. Why not?" I don't get it, but maybe there's a good reason. I don't. The canonical example they show in the text here does not look like the poster child. Does not look very poster child-like. I just said, drop that, and it's all identical, and we're all happy. And why the hell did you put it in? So fine.
I've got good news for you, but it's not in Java.
There you go. Well, that's why I'm at where I'm at. I've got a very simple, but I guess Java was first, right? And it's not first, but of course, it's very, very old. That's obviously, yeah, exactly. Smart casts. Yeah, I totally get it. That notion's been around a while. Just the implementation in Java where you optionally can put another variable there seems excessive. The optional extra variable, I'm still trying to sort out why I would ever.
I guess to respond to that, I could say that if you have an if statement where you do an instance of, and maybe you have 200 lines of code in there, and you're looking at the middle and you see, oh, I have an O here, a variable O, and you want to find out what static type that is. Now that is, you can't just go to the definition and see the static type anymore. You have to figure it out how many nestings of if, instance of am I in to figure out the static type. So I think the new variable name is a little bit more.
I would claim that's the IDE's job, but okay. Take me back not to the death of O, but to the last time O's type got sharpened semantically.
Yeah, but that's trickier to figure out than just being able to go to one definition and figure out the static type.
Yeah. And what you're claiming is I have incremental typing via a series of nested if statements, each sharpening the value for O. I actually then only care for the innermost sharpening. What value did O end up as? That's the innermost sharpened value. I think that's not too hard to get.
Yeah, but
if someone's changing O, then all bets are off and you should be smacked around because you have a variable that has a lot of complications running around, and also you're changing it on the fly. I think that's a, by default, O should be final, and that didn't, the change, it's not the change issue. It got sharpened and if sharpened and if sharpened and if sharpened, and now I'm using it down here. What's its type? Well, I claim the innermost sharpening was the sharpest, and therefore that's the type of excitement. And I don't need to track the chain or find the original def. I'm more excited about the last sharpening. That's an interesting point, though. I mean, very clearly.
Still two kind of sources of truth you can find. Maybe you can, right? It's still, I'd argue it still burns a few more brain cycles to figure it out if there's two sources of truth. One
right,
is the
I'm with you.
Declaration of the static type, and the second is the if sharpening, and maybe there's multiple if sharpenings.
Right, yeah, I'm with you on that. I'm thinking through changing my tune here. Like I'm doing the sharpening thing, and by default, all variables are final unless you make them variable. This is the same as Scala, so you don't have the changing value issue nearly as often, but it does come up with two sources of truth if you're trying to figure out what an expression means because you walked through a sharpening.
Well, the other option is to not have 200 lines of code in a method.
Well, but people do what they do.
Right, but the compiler is going to tell them if they're doing something wrong. I mean, that's the purpose for the
But the goal is to write code that by default is easily readable. By default, by somebody, I don't know who.
By somebody else, yes.
Yeah, right.
Agreed, and that's, I think the addition of that variable actually tends to hurt that. Although I'm not used to it, so maybe I'd sing a different tune if I used it for a couple of years.
So
but, once I check if something's a string, it's a string, right? Like.
Right. in my world order, it's easy to add a variable without having extra syntax in the language because I can take defs anywhere, including right where you've done the cast. So you could just add var equal, name foo equals cast of O, and now you have foo as an O type forever forwards, but the scope of foo is limited to the cast, and O's obviously sharp here and dull elsewhere. Yeah, okay, fine. So there is something there where you want to have another variable. You're claiming because you want to not have to, because you want the def point of the variable to be effectively a final assignment to this proper sharp type so that I can have a quicker understanding. Maybe. I'm recanting.
I mean, I'm sure for the people in this room, it's easy enough to figure out what the actual type is, but
yeah, but I think that's not the metric. The metric is what do we think the people who use the tools we're writing will want, or will help or not help or whatever. At least that's the kind of the metric I'm heading for. It has to be good for me. I have to enjoy what I'm doing. I have to read it and write it and like it. But also always there is, what is the sum total of average number of abusive questions and comments I get over my lifetime on this language feature or that language feature? The answer comes back, well, we all hate the if instance of string of X is equal to cast of string and string and string and string and string and string. Okay, get rid of that. Fine. So that was, that's an obvious, let's go clean that up. Can I read it? Sure. Do I hear other people's pain there? Yes. So what you said was there's some pain involved in going through one of the sharpenings and then using it much later. And if you go back to the def, well, the def's very generic. You have to go back to the sharpening. And there's many sharpenings. And you want the innermost one maybe, but still and I'm with you. So here's a similar question. If I take a thing with many subclasses and I sharpen it slightly, I have, generic object gets sharpened to node, and there's an XML node, and there's an XML subclass node, and I don't know what the hell. And I go through a sharpening that is redundantly useless because it was sharply typed above. Do you make that an error, claiming this is a completely redundant sharpening, and in fact, you're going to a duller type, and we know it's a sharper type, so it's obfuscatory to say it's only as sharp as an object when we know fucking well it's an XML node? Or do you just let it slide by and say, yeah, it's a junk cast, and the IDE pops it up in gray and says, this is a junk cast? But
we make it a compiler warning, possibly a compiler error.
Compiler warning, this is a junk cast. You probably don't want this because you are dulling a known sharper value. That's fair. I'm kind of looking at these I'm looking at these kinds of things, like what's the right level? If I know something and you're telling me something weaker, do I want to say something about it? It's like, I can improve this assert, doesn't do anything. But actually I like the assert in the code because it's documentation of a belief I hold. So I don't want a warning on an assert, even if I can prove the assert is junk.
I think you have to look at something like that and say, can it be useful? And if it's not useful in any way, then I think things like that should just have be blocked by the compiler, because ultimately less possibilities makes the program easier to reason about.
Yeah.
And the reason you're asserting it is because you want to be certain that it is, because you're about to do something with it.
Yeah, I'm about to change.
If you try to do something with it and it's not the right type, the compiler should tell you that too.
Yeah, but probably if you're doing an assertion, it's in a place where the compiler can't guarantee the condition holds, so you have to write something yourself.
I write asserts as documentation, as well as quicker catch the bug, but they're frequently, here I have a belief that I cannot express in the language. So you're correct, the compiler, it's not that the compiler doesn't know, or the optimizer doesn't know, it's that I cannot express it in the language directly, right? So I have to use an assert. in the old bad days, pre-decent things with nulls, I had a lot of issues where I knew things were not null, but I had no way in the language to assert it. And junior engineers would come through and add, if this is null, then do that. But they didn't have any error recovery thought through. And so their error recovery code was crap. But also it couldn't actually happen. So as soon as they added an if test with broken error recovery, you got confused. A null can happen here? Wait, this doesn't recover. Now I want to debug this recovery code that can't ever happen. It was like worse. And I really badly wanted to have a way to say not null as a typing thing. And when I couldn't get that, then I would assert not null, even as I knew it wasn't null. And you could go look and see that it could never be null, but you had to have the assert because somebody wasn't looking enough. And they were like, oh, I have to add null handling here. No, stop.
Well, the alternative is to use Git, so they can't add that.
No, it didn't help. They'd still do it. It's just like passing arguments to functions. They were belief that the argument passed in as a function was a null, and it wasn't. It couldn't be.
So looking at this syntax of the instance of with adding the new variable name, I think they had to do that for backwards compatibility. So imagine you had some code today where you just said the nice thing, right? Object instance of string, right? And then inside that scope, you pass that object to some function, right? And there's a version of that function that takes object and a version that takes string. The old code would have gone the object route, right? But if we introduce this feature without introducing a new variable, it would go the string route, right? Changing the behavior. So I think you have to, preserve the old code, you'd have to introduce a new variable with its type.
You're saying...
I think you're right. I think that came up on the mailing list as well as one of the main reasons.
You're saying without changing the code, just changing the strengthening of the type in the region.
Yeah, let's say I have some old Java code, right? Yeah, that says object instance of string and then says foo passing obj, right? Yeah. If there's two versions of foo, one that takes obj and one that takes string, the new version would go the wrong way, right? And we'd break backwards compatibility.
If you recompiled, yep.
Mm.
If you recompiled, yes.
Oh, if it's statically dispatched, which I guess it has to be in this case, yeah, fine. Yeah, you have to recompile it to break it, but it would break.
Yeah, it struck me as it had to be a backwards compatibility thing, right? It's like, it's not the desirable outcome, right? So in a new language, don't go this way.
Right. Right. So there should be a comment in here about that somewhere, because that's definitely, I swear there's a much more aggressive, I guess this discussion is just sort of where it's at the moment. There was a much more aggressive pattern matching discussion going on.
Yeah, that's on the Amber. That's on the Amber mailing list.
Because this claims it's Amber, but it's like status closed delivered. The discussions on Amber, this is just pattern matching for instance of IC, as opposed to more generic pattern matching, right? Okay, and then here is a more generic. Yeah. Here's the generic. Yeah, I follow the link for the generic pattern matching now. So what do people believe on top to bottom if test patterns versus complete destructors where you're known they are all the compiler will tell you if you're not completely orthogonal. All options must be mutually exclusive and the compiler knows it, versus I just ran a bunch of ifs top to bottom. No one has an opinion.
We do both.
You're going to do both?
Yeah.
What's the
So we have a model we call an if ladder switch, and we have totalitarian total analysis as well. So if you're matching against particular values, we can determine totality.
What's a switch ladder look like syntactically versus a stack of ifs?
So the switch expression looks like that, and then the cases are actually booleans. So it's literally an if ladder.
So you just write a Boolean expression colon thing, Boolean expression colon thing, Boolean colon thing.
Yep.
And that's just if down the line till one triggers.
Yep.
as opposed to if expression, then else, curly braces,
Right.
else, then if.
So
else.
the problem with the original Java rules is that you can't have any overlap between the values. And so we support value ranges, and we support, so for example, we could say switch, X, Y, Z of any various types, right? And then, so you could have X as a char, so you could say A dot dot Z, and Y, in this case, you want to match anything, so you put underscore, and for Z, it could be an int, so you could say 5, 7 dot dot 9, or whatever, like you could fill in multiple.
But your patterns were not disjoint, provably by the compiler, or?
So what it is, so in that style of switch, you can have a pattern that comes later that overlaps with one that comes former. And then the order matters.
Yeah. Okay. You just fine. You're applying
Because you could either say default, or you could say case this, comma this, comma this, right? And those theoretically are the same meaning.
Right.
So the underscore is.
The question is, do you demand that the earlier patterns have something they'll match ahead of the later pattern?
So yes, if they are compile time constants. So we have 3 categories. We have compile time constants, which means I know it's the number 4. And that number is an integer, 64-bit, signed, unchecked, whatever. Like, I know everything. The third case is it's a variable, right? The middle case is I can prove it's a constant, but I can't prove its value. And this is one that's extremely handy. So for example, in Java, you can have a field static final I'm debugging equal false versus static final I'm debugging equal true, which is really handy if you want to recompile everything in the universe that might look at your debug flag. But if you don't want to do that, you can't use it in the switch, right? So like, in other words, if something looks at that and puts it in a switch, it'll put false or true in the switch, not a reference to your field. So we actually maintain it as a reference to the field and let the linker revalidate the linker loader, revalidate the linker loader verify, revalidate the totality of the switch. So
what do you do if he fails?
Well, in that case, you'd have to have an explicit default if it's a switch expression.
I mean,
what do you mean fails?
It's not total because somebody screwed something up. You get a compile time error, except you're doing
right. So you have compile time total, verifier total. Those are the 2 options. So if it's compile time total, you can reprove that easily at verified time.
Yeah,
but if it's not compile time total, you accept that it will be total at runtime based on
the verifier.
And then the verifier has to prove it. That's right.
If the verifier fails, what do you do? What's it do?
You don't load that class.
Okay, fine. So class load error.
Right.
Okay,
which may prevent the container for the type system itself from being formed.
Yeah.
You have to transitively close over the type.
I was trying to make sure there's some sensible behavior. That's all fine. That makes sense. No, I was really looking at
which languages allow for this construct, for this multi-variable switch case?
This is ecstasy.
But
also OCaml does in a lot of ML related family languages.
Yeah, OCaml. I want to say Haskell, but maybe I'm thinking ML. There's several of these, and they're very handy. And I was trying to sort out in Cameron's case, what was his opinion on switches that were partially overlapping or partially occluding one to another. Do you apply the switches in order if they're partially overlapping, or you demand that they overlap strictly like in a tree-like fashion so the later cases can completely catch all the leftovers from the earlier cases, but there's no, but if you
that's what default is, really.
Well, that's what default is, which is an easy catch-all at the end, right? But suppose since you have 3 variables here, your X, Y, Z, suppose I catch, blank, blank 7,
right?
Or,
exactly.
or blank 5 blank.
And what's really awesome about this construct that I never imagined until I had it to work with is state machines become super easy to write. It's just while true, switch, ABC. And then it's like, okay, if that's true and that's between 4 and 7, and Like, it's unbelievable how easy it is to write a state machine with a single while loop.
Elm's entire purpose in life is to go make a giant switch statement for reactive programming for web things. And it's all about the giant ass switch statement with the big pattern match.
And the other thing I've learned is that once you have multi-return values from functions, you'll never go back to a language that doesn't. Like,
yeah,
it's,
I figured that out too.
It's excruciatingly painful to work in C, Java.
Yeah, I'm with you. You know, in the sense that I do workarounds all the time for the lack of it, but if I had them, I just wouldn't do a workaround. Just do the right thing. So yeah, and Elm does multi-returns all the time, and it's very nice there too. And the most obvious one is simply, I have a thing that's got a 2-element union. It's either okay or an error. And if it's an error, you got some sort of stack tracy stringy error thingy. And if it's an okay, it was whatever the hell it was. And all of the, I did the right thing or I blew out and I'm trying to gracefully unwind where I can recover, all do this kind of thing. And you have 2 elements come back. You have a Boolean and some payload. So no, I didn't get my question answered. That's what I was trying to get at here. What do you do with overlapping patterns where there's ambiguity, which can be resolved by the order in which the patterns appear, or by claiming that you're not allowed to have ambiguous patterns? Elm, yeah, there you go. There's Elm docs too. Go find people. I should do that for folks here. I did a lot of programming in Elm a couple years ago. It was pretty fun.
Yeah, this is a video with Evan. I'm going to butcher his last name. I apologize. Zaplicki.
I never tried. Evan. I've talked to him a few times. He's the same guy, and he's got some opinions though that I don't necessarily agree with in language design. But you know, Elm does what it does very, very well, and it does some other things it could do better that I claim suck for no good reason. But I have language opinions too. What the hell? Sorry, and I sent it to Matt privately. Let me try again here. I failed here. There goes. One of the fun things you get out of Elm is complete determinism in the debugger. He'll record all of the events if you put it in debugging mode, including mouse clicks where you're tracking your little flash game and things are bouncing and jumping about. And then you can replay them in the debugger perfectly every time and watch it go in slow-mo. So he captures all the IO events and is able to play them back. And that is so nice for debugging these reactive things.
Yeah, so you can go forward and backwards and just use it almost like a video kind of thing where you can just, no, I want to go back here now, which is really nice because we all sort of thought we were paying attention and we move one step forward and then we go, wait, I needed to know that thing just a moment ago. Damn, now I got to rerun it again. And you don't have to do that in Elm.
1,000 times a day, I run one step too far and I go back to hit the rego in the debugger and stop it one step earlier. Yep.
I think Dark is using Elm under the hood. Darklang.
Darklang. Send me a link.
Reason, I thought. The OCaml front end.
So is it related to Elm, Max?
Reason is not related to Elm. I worked on Reason Bit as an intern. It's a whatever it's called, OCaml Yak. No, it's Menhir. It's a Menhir front end and some compiler transformations.
Put the link in the chat.
Yeah, I will. That's a good idea. Oh, I almost sent it to Cliff privately.
There you go.
That's how it happens.
So there's evidence of a bad GUI design.
Yeah, but Reason is a strategy to make OCaml more approachable to people who work on front-end things by making it look like JavaScript but still be sound and all that. And it works remarkably well. And it generates good readable JavaScript too. It's not just like trash.
Elm and JavaScript with Flow have been what I've done front-end work recently in. And Flow is JavaScript with types. This is pretty nice. Except where they couldn't do it and you had to cheat and say, okay, and here cheat.
Yeah, you do a bit of the same when you're doing like document dot whatever. You have to have that bridge where you cheat on the boundaries, but it's kind of expected, I think.
I would have to stare at OCaml. I have not done it enough to have my OCaml head on. Interesting.
Let me get a page that has some good, like a bunch of good examples.
It looks very suspiciously Elm-like as what their little examples show, and I'm like, smells like Elm, which is based on the Haskell backend for type inferencing, but obviously spits out horrible JavaScript. I'll be honest, Elm spits out horrible JavaScript.
So the secret to the good JavaScript code gen is this guy Bob Zhang at Bloomberg wrote this thing called BuckleScript, and they had this partnership, and then eventually Bob was like, all right, I'm going to work on this full time and left Bloomberg, and then now they renamed BuckleScript to something else. I don't remember what, but BuckleScript is like the secret sauce for very readable output.
Right. The answer is it's hard work.
It's very hard work.
Machine generate readable code. I have done so in the past, and I know what it is. It's hard work. Oh, here's Darkline now.
So Elm was based on Haskell and OCaml. Yeah.
On
Haskell and OCaml.
Haskell. OCaml. I knew it was Haskell. I didn't know OCaml. Serverless backend. Give me some code examples. I would have to stare some more at it. I don't want a video now.
Dark is very interesting. I got an early invite, and it's so much GUI stuff where like you put lines between boxes, and like you basically have your backend written as sort of a weird blob of boxes. I wonder if I can do a screenshot or like a screen share or something, but
yeah, and
I could not figure it out.
You write it on exception, right? Like it's like, okay, I'm done. You put the first request in and it pops up and says, oh, you haven't implemented this URL. How do you want to do it, right?
I don't know. I never got that far. I couldn't get to the point where I wrote a working request handler because something didn't click for me for like, this is how this indicates this is a request handler and this is how you, I don't know.
But it seems to be designed for iterative development, really fast iterative development.
I believe it.
So I used to work on a 4GL, so I love the ideas. So
Elm has the opinion that everything has to be type perfect before you hit go, and getting past the compiler is a bitch. And once you do, it almost always does something useful. Like it doesn't crash now, or it cannot crash. It will almost always do something useful. But getting past the compiler is a bitch.
Same with Haskell, but they still have like unimplemented or something, right? They have this thing that fits any return type.
You have debug.crash for Elm. That's your unimplemented, which is fine.
Well, that's cool. We did to do.
Yeah,
so
I'm going
to do is an expression of any type.
Right. I'm going to do a ... as my to do as a expression of any type. But you want to have something that says I'm not done yet. But you had to actually put a type in for debug.crash. You had to say what type of the damn thing was. And then you put a string in there too. And then if you ran into it, obviously it barfed. But otherwise, mostly you had to get past the compiler.
The other cute thing with the Elm compiler was because of that, they could also, you know, when you did fail the compiler, it's like, did you mean to do this? And you're like, yep, thanks. It was really good at just figuring out what you were trying to do and telling you, and you go, oh, thank you.
The error messages were interesting, yes. Yes. Some of them, it needs some help though. I don't know. I have these giants. It's a state machine for reactive programming. It had all the states at the top level. So I had a big complicated GUI. I had literally 100 switch elements. I screwed up one because I added something to the base structure, I added something to the type union, add something here, add something there, add something there, hit the compiler. Oh, I forgot to add an element in the switch. So he dumps the entire switch out and says, and oh, did you mean this +1? And you didn't need to puke the 100 element switch.
Well, I think on one hand, when you first encounter it, it's really nice and kind of cute and you like it. Like, this cannot always succeed. You can't always have a compiler be so smarter than you.
Fine. I'll give him credit
compiler-
for trying hard and mostly getting it right on the error messages. That I'm doing error messages a lot now, and it's pretty
There's
hard.
nothing harder in compiler development than error messages. That is
right.
that is the hardest thing. in
I took your
compilers.
program,
And
I
if you
worked
don't
on it
believe
for-
me, look at the first 15 years of C++.
Oh,
What an abomination. I had to get a
Oh.
4K monitor just to see the errors.
oh God, they were bad. I told you, I was there. I was doing that shit. This was like, and Hotspot started out as C++, but we trimmed way back on feature sets because there were some that would just, like, anything to do with templates would just puke at you just horrifically. Oh my God. And you had no clue what was broken.
Generics brought those type of errors to Java, right? Like when
Yeah.
you get a generics error, it's as bad as anything with C++ templates.
Right.
What
the hell
has these
happened?
errors changed? Like, I feel like every time I do something with an O stream, it's 20 pages of template something. Like
I'm not doing C++ forever now, for a long time. I'm happy. Backtrace at compile time. Yeah. This is the deal that Elm has, and I'm looking here, is that I ran a type analysis for a long time, and I cannot finally end up resolving all types. And so I know for a fact that you have a type error. Okay, but I have gathered bits and pieces of typing knowledge from all over your program. How the hell do I report this? Right? You have failed because you have failed. And it becomes really hard to say in a concise, easy manner, this is why. Yeah. So I do a lot of games up front where I catch certain common error patterns, but the generic worst case scenario of I failed to get a typing, you have a type error, but I have gathered types from all over your program and they do not resolve together. I'm not clear on what's a decent reporting strategy. You get something out now, but it's not. It's the Elm problem. You get something. Elm had another problem that he curried by default, which meant that if you dropped an arg by accident, it would be syntactically correct. But what you got back was a function missing an arg.
That's right.
Not the execution of the function.
Which is why using val and var and whatnot, for let without a type ends up being an error in a lot of cases, because you haven't told it what you're looking for. You wanted an int and you get a function.
Yeah, and then he carried on for a while before it blew out, and then he's all confused. So that one, I think I'm gonna declare currying is not by default. You can ask for a curried function and it'll curry on demand. But the default behavior is if you've missed an arg count, you'll get an arg count error.
The alternative is that you use a token to represent the uncurried portion.
No, that's okay. What do you mean by the uncurried portion? You curried, so you got a function back that had some arguments and some are not yet.
So you have foo that takes 3 parameters and you say foo ij. You can make that a compiler error, right?
Right.
Instead, they should have said foo ij. Let me get back to you.
Oh, you demand the user explicitly curry this way.
For example.
I'm in the opinion that functions should be not curried by default, but you can ask for currying on demand. Here is a way to ask for currying. This was not the technology I was going to use to ask for currying, but I kind of like it. I'll have to stare at that now. I'm all good with curried functions. I'm all good at trying to figure out.
The other thing
better
is
answer actually, because the usual story for the curried function thing was that I intended to curry, but I curried the wrong variable, the wrong parameter.
And what if you wanted to do this? You wanted to say, let f equal this, right? And it's like, okay, f is int, it's 4. And it's like, no. I wanted a function, right? So
right.
the other.
So I have the problem that oops, we come over here, type over here. How do you curry this? And the answer is your underscore technique works great. In Elm, you do this argument swap functions that mutate the args around such that the one in question becomes the last, and then you supply 2 args and not the last, and now you got the right curried thing. But that's a nightmare to read and debug. Whereas what you just said there, where you put the underscore where you want to curry, I like that a lot better.
There's one other edge condition on it, which is you may have to, if you have overloading on types, you could theoretically have that underscore or some sequence of some combination of underscores correspond to a column in the call graph that has more than one function. So you might have to specify a type unless you have late binding.
Well, I'm doing type inference, so I'm totally doing overloaded functions and totally doing type inference. So if you curry, you get a new function that's just missing the variable, and then when the variable shows up, that's your type value that's going to.
So it selects the function at that point.
Yeah.
Okay, good.
It's all still ahead of time typing. None of it's done at runtime. It's all ahead of time typing, but the typing point becomes where the last argument appears, or the function selection point becomes when the last argument appears.
Yeah, we have type intersection, but we don't have function intersection. So.
Okay, no, I do functions fully throughout. It's pretty crazy. I'm having, like I said, I got to do some amazing shit, and I fail on some stupid things. So it's not the Haskell type inference engine by any means, and I can do things that Haskell can't do. It should, you fake it in Java by just writing functions that you have to write the wrapper yourself. This is in the chat here.
Yeah, so Java doesn't have functions, unfortunately.
You just
it
write a
has
function.
Fake method handles or some.
Right, you fake it, which means you have to have the function as a static constant, and then you can wrapper other functions that take different argument counts, but it's not currying. Compiler doesn't care shit. This is the language, and the language semantics, but also the language internal representation as a class format and method handles does not well suit itself. You'd have to major effort to get the internal runtime structures to admit for currying.
I think some of the decisions they made over the last decade will make it even harder because they're going to have to back out of some of those alleyways.
They went down a lot of funny paths, and I said, hey guys, there's a better way to do this. And I tried to talk them to them at JVM Lang Summit, and they were too late, too far gone. It's like, okay, I'm out of this place anyhow. So do what you're gonna do.
So that's if you want to do late binding as well. But can't you use lambda expressions to do something similar, like insert several arguments and then return a new function?
That's what I'm saying. You can fake your way forward, but it's not currying. But you have to write another function that specifically is just taking the missing args.
Yeah, okay, I see what you mean. So you want more of a language embedded thing.
Yeah, right. And you could argue that lambdas are the reasonable way to go forward here. There is a way forward that's not truly gruesome, and lambdas make it nicer. I was first thinking of just being the gruesome thing of like, I'll make a fucking inner class that's got fields to hold the partial values, and then I'll call your function when the rest show up, and I'll make but that's a lambda. So yeah, I didn't think about lambdas making it better. Lambdas are not too far off. But what Cameron just wrote looks a hell of a lot prettier to me.
I'll take that.
This is all about writing a readable language that still does the things that you want to do. We've got a lot of language improvements even in the last 10, 20 years still. It's still ongoing improvements and things. So now come up with the right syntax and the right implementation and make sure you can run it performantly. My goal is to still be able to run everything high performance. But I want to have first-class functional programming with all the bells and whistles, and I think I'm going to get there.
Can you explain what does it mean, a first-class function language, in terms of the technical implementation of that? How would you?
I have closures. I have real closures.
Yeah, but how do you implement closures? What is the difference?
In the worst
languages that support this.
Right. In the worst case, closures demand an allocation of your stack frame because the lifetime of the stack frame exceeds the function execution. So the worst case scenario is, so an unoptimized with full functional, first class functions with full closures, you do an allocation for every stack frame, not stack allocated stack frames. So they ain't like a stack no more. And that costs you huge in performance. So all modern hardware optimizes your stack frame behavior a lot under the hood, whether you believe it or not. Even the really simple guys do this. As soon as you walk away from that model, life got a lot more expensive in a lot of fronts. I'm having first class functions means that you can have closures you close over and they have internal state. If you do that, I'll do a malloc or a new or whatever you want to call it. If you do not, you get a stack-like behavior. So it's a pay-as-you-go model. If I can optimize my way to saying that you're not using upwards exposed funarg, an escaping function, however you want to call it, then you'll get a stack allocated stack frame and life is good. And if you do an upwards exposed funarg, there's a new under the hood. Yeah, and the lifetime of the new has to be tracked, however that's done.
I'd also say that to be a first class feature of a language, the type system has to know about functions and functions have to know about, like there's a, it's a tight coupling between your ability to hold a function and to represent it in the type system. So it represents a dimensionality that most type systems don't have, because you have, so if you look at Java, I hate to beat up on it, but I know it better than a lot of languages.
Everyone knows it too, so it's fair game.
So it's like you have one return value and you have one parameter. So your function has two parameters. I'm sorry, your type has two parameters, right? Oh, I want a second parameter. Okay, now your type has three parameters. Like you only have one dimension to work with, right? When in reality, parameters are themselves a first class object in your type system. So it has to go deep, not, it shouldn't change the arity or the indexes thereof of the.
It goes in the other direction too. So if I pass a pointer to a struct which has fields that have pointers or structs and pointers or structs, the fullness of the type expression includes that depth of all those pointers. That same holds true with functions, where the magical difference with functions is they can point back to themselves in the type hierarchy, and that's a recursive function. Yeah, both of those. Lambda lifting, yeah, this is a good wiki article. I've read through this. There's a bunch of ways to go back and forth to think about how closures mean. Semantically, JavaScript, have you done any JavaScript? JavaScript's got full first class functions. With full first class functions, you get to do a bunch of behaviors you can't do otherwise, including put a lot of state inside that closure that's been closed over. And that's before they had modules, that was their module system. You wrote an entire module system in your core base language because you have first class functions.
We call it Node.
Sorry, go ahead.
I said we call it Node. I mean Node
got there first officially. Then there were a bunch of follow-ons, and then there was like ECMAScript finally got in the act and said, here's 5 different module variations, of which these 3 come from the Node community, and these 2 come from somebody else, and this comes from here, and we'll make them all semi. Yeah, it's like Java. You know, they didn't have it right in the first go round, so people made something up, and then now there's 5 variations thereof. But there's something sensible, kind of, sort of now with modules. I guess, but the first thing take from it is hidden state that you expose via an API, via function calls. I return you a function to go do something on the hidden, or a set of functions to go do something on my hidden state. Here's a let me see if I can do this here reasonably. I was going to do a Slack channel for people to do thing here. Okay, so here's a horrible function. It makes a variable called count, which it doesn't expose. It returns a pair, a tuple of functions. So if I just do get inc, do this here equals gen. So get and inc are now two functions. One will get the value of count, and one will inc side effect internally, but you can't ever see. Yeah, and curly's always make a function. And if you don't have any, or you don't have an arrow in there, then it's a no arg function. So these are a bunch of no arg functions. And if I did this again, I get a different set of functions, gen2 and inc2, or get2, should have been get2 and inc2, which are a different counter. Those are independent states, the two different counts. Every time I call gen, I get a new counter. Has independent state out of the lifetime of gen, which means I have to allocate it storage somewhere. It's not on the stack anymore. And therefore, it's an allocation. It's a malloc or a do. That's something you can't get without sort of full first-class functions. If I was to do this equivalent thing in Java, there is no way, well, there is no way to make the equivalent thing without putting a class in. And as soon as I say I have a class for the outermost scope, I had to say new, and that was in fact the allocation that made the object.
Well, you can do it as long as you don't modify the count, but you do.
Yeah, and the other way to do this is you have it with lambdas, which you say final for everything, and they actually, instead of doing a malloc, they share the original value. I think actually for performance reasons, they clone the original value to have a private copy, but they still stack allocatable now because it's all constants. Or constant from the function's point of view. Does that help fill in, Han? It's kind of these things you want to go code in that language for a while to do something sort of semi-serious. And then it becomes obvious what's going on, and suddenly the sort of the world opens up. Oh, I can do this and this and this. There's all these cool things you can go do suddenly. If you're not in that world, you don't do it. You don't know. It's like, I don't know, world travel. If you don't go around other nations, you don't have a clue. And they live their life and you live yours and you see what's on the news, but it doesn't help you very much. But you go live it just even a little while and you, oh, this is okay, this works. And suddenly, wait, there's shit you can do here, like have real public health care and not the current US system, whatever the hell. I'm just saying there's a dimensionality here that doesn't happen until you live it.
You socialist.
A pretty strong capitalist under the hood, but there is something fucked up with the public healthcare system. So maybe I got some socialist tendencies. I don't know. Fine. No. Well, here we are. It's 11:30. Okay. I'm gonna go stare at the mat here. What did you throw up? We got a, oh, look at this. This is not Godbolt. This is a different one. I have to keep turning on all these. What is this guy doing? I don't know how to read this code here, Matt. What the hell is he doing? What's the square brackets in the front?
Are you in the first example? Are you in the first example or in the second example?
Okay, I got audio quality issues there suddenly.
Are you in the first example or the second example?
Well, I don't know the syntax enough because, so I'm looking at the first example. There's auto, which is a variable, fine.
Okay, so this one adds 2. So this is just a simple lambda. This is not yet really a closure.
But what's the square braces mean?
And the square braces are, square brackets is the list of captured variables. So here we do not capture anything from the enclosing environment, so it is empty.
Wow, that's a weird ass syntax.
So this is very useful, but bear with it. So this only adds 2 to wherever is passed as an argument. So
I see. Yeah, this is you're doing a lambda capture. Yeah.
Now right. Switch to the second example.
Yeah.
So you see here you have J. That happens to live on the start frame of main function.
Right.
Now inside main function, we define the function f at J or the lambda, and now you capture J.
Yeah, I got it.
Captures J or captures the value of J?
So in this particular syntax, you capture by value. You can customize this. You can capture by reference. For example, you can also move the ownership by capturing the unique pointer, but by default, you just mentioned this, you will capture by value.
Back up. If I capture by reference
on the stack,
exit main, and the reference was kept on the stack and disappeared, and I got broken code.
You do not want to be passing this around outside of something that could outlive main. Yes, memory management is on you, as always.
Okay. Fine.
As always.
Yeah, fine.
So
it's always wonderful. Always wonderful to have a language where you can have a union between void star and int.
Dude, you know, the hardware doesn't care.
Yeah, no
He was all about better than writing assembly, but do everything the hardware can do.
After that example, I'm not sure that it's better than assembly.
Well, no, he's capturing J by reference to the stack frame. That's just a bug waiting to happen.
And capture by value here is actually not bad when you do something with concurrency. So I kind of like this as a default, because most of the time you will capture a lot of small variables when you split something to be executed by multiple tasks. Like you will just capture integer denoting the bounds of the space that you are, iteration space you are partitioning. And then I'm totally fine to copy this, and I don't want shared mutable state. So if I copy this by value, I never have to worry about any race conditions because it just copied in to the frame of the closure, and it will never be stepped over by another thread. So I kind of like this default I think captured by value. It has its positives.
Cliff, how does your language do this? Because you can still modify count, but every time you call gen, a new count is allocated?
Yeah. So gen returns you a pair of functions that modifies its internal stack frame, but the stack frame's not a stack frame anymore. So it's
so how does this work for loops? Let's say you have a loop body. So you have for I is 0, I2, some length, and an I++. And in the loop body, you're spitting out these closures. There's only going to be one I, right? So you're gonna...
loops, separately from closures to loops. Yeah, for a loop, you're talking about putting. Okay, keep going. Then what do you? If you write some fake code, I can infer here. But I hear you say for. I have a loop with the I as an iterator is changing all the time.
Yeah. So you create 10 lambdas in the loop body. Each iteration you create one, and you capture I. At the end of your loop, they're all gonna still point to the same I, so they're all gonna have the same value as right. So you have to do a copy, right?
No, I'm not doing it. It's by value.
But it's a reference to the stack frame, right?
The assignment takes it by value.
Oh, I think there's a confusion here. The reference to the stack frame, it seems to be inside the call to this gen function. It's not inside the loop.
That's correct.
So it's another nested frame that then gets copied onto the heap.
The gen would have to get copied onto the heap.
Yeah, not the loop frame.
Not the loop frame. That's correct. The loop frame is just a value copy. So I modified gen to be a function that captures I, like this. Okay, so here's a function just captures I. Okay, this I'll barf at you because I is not defined. So instead, I have something that says here. I'm going to define I here. We'll do what you're doing here. I have I equals 0 for some predicate. I don't care. And then here I'm going to say, gen is equal to, well, I have to do lexically scoped on gen. So I have to have a definition here. So oh, okay, here it is. I have to do it ahead of time. We can get this yet. Gen equals count equals I. And that's not actually going to, yeah, it is. And then gen. So something like this, where pred was an arbitrary my loop exit predicate, y equals 1 to 10. I have to declare gen, because it's using I, in a scope where I exists. Now I'm executing gen in a function body I'll make 10 instances of a gen. Now, gen isn't, I'm not doing anything with gen yet, so I have to have gen actually return me a pair of tuples and the initial value of count. So you could keep expanding this and have it do what you're thinking. Take all the gen things and throw them in an array and reference them later, and you get 10 allocations. It's as if I said, gen is a class object. I made 10 class objects. Each one captured I. If in Java, I would just say, for I equals 1 to 10, I have a new class object that captures the initial value of a count variable to I. But I said new 10 times in a row.
I'm going to translate this into Python to make, and I don't know about other people, but I'm not exactly familiar with the syntax of your.
Well, I'm making it up as I go.
Fledgling language. Okay.
So no one else has it. So I would totally expect you to not know what the hell I'm doing. I mean, it's not being made up as I go in that sense, but I'm writing the language now, and the syntax changes fairly often, and it's slowing down. But I haven't written any big code. When I start writing big code, I'm sure the syntax will change a bunch. But we're talking about lambdas, and so you have to go to a language that supports sort of real closures, which I don't know if Python does. Do they have generators? They might have real closures.
No, they have closures. They have closures.
No, uppers exposed fun args all the way. There's like not Java has lambdas, but they're not closures.
I'll post a snippet.
Right, so reasonable cogen is up to the eye of the beholder. If you don't want to allocate storage, don't. There's a different thing that says, oh gosh, get past the README here. Da 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 da. Yeah, now you're modifying the variable outside because you took a reference. Yes. Oh, and you only call it once, so the optimizer saw through it. Yeah, right. If you only call it once, the optimizer sees through it. I'll see through that too if you only call it once. If you the gen function I wrote, it won't allocate a stack frame if you use it in a context where I can see that the call limit is limited, and then I'll inline it. I'll inline it in the type system. Fuck it, and you know, optimize it through the type system. But if you throw it in a loop, so like what you didn't show in that Godbold example was write the thing in a loop. Yeah, there's a limit. The thing that I'm intending to do and have not done is have a type system annotation that says, and thou shalt not allocate a closure, a heap, or whatever, thou shalt not allocate. And if the type inferencer cannot get away from heap elision, he'll throw a type error at you and say, I have to make a stack frame here, or I have to do it in malloc here. And you told me no. And then that tells you that you got too fancy with your local closures, and you need to simplify in order to not have a stack frame or live with the heap allocated stack frame. Yeah, here you go. Here's a function, returns, well, what's the function doing? Just returning I.
So you store a bunch of
fine.
Closures in some array. And the idea is that I was wondering, because you're not copying I when you capture it, so every time you for whatever function in the array you call, you get the same I back.
I'm in the example I was trying to write, I'm capturing I every time gen executes, which is every iteration of the loop. So it captures I 0, 1, 2, 3, 4, 5, 6, 7, 8.
Yeah, so that's a workaround for the problem.
I'm confused as to what problem we're talking about then.
That you always get the same I, even though you want to capture the value of I.
If you want to capture the value of I in the sense you want to capture the reference to I, sorry, not the value of I, but the reference to I, then I has to be inside the closure that's in reference.
But it is.
Yeah, here the closure being curly braces for Cameron's example, you have I is actually included in that scope because it's outside that scope. It's included the for loop, and because you have it captured, you can modify.
In Cameron's example, is arrow denote a lambda?
Yeah.
Okay.
Yeah, but you have access to the scope. Now, where does the scope of I end? It ends when you leave the for loop, right?
In this case, it ends the later of when you leave the for loop, and when the last read-write function ceases to exist.
Okay, so as soon as you, on the read only, you actually do something there different from the read write?
It captures a value in the read-only one.
Okay, you had.
Actually, no. In this case, no. I take that back. I apologize. It captures a read-only reference to I.
Yes, I capture the read-only references as well.
I'm slower than the compiler. Sorry.
Yeah, it's fine.
So we'll capture the value if it's effectively final. We'll capture a read-only reference if it's not effectively final, but the lambda does not mutate it. And we'll capture the read-write reference, what's called the var, if the value is not effectively final and we modify it. Hence, obviously, it's not effectively final.
Right, I'm doing that behavior. I'll capture the read-write behavior if you're in scope.
And it's obviously not. It is not the behavior you would want to see an introductory programmer using.
No, right. No. This is all kinds of fun uses, but they get.
Yeah, I mean, you're dealing with it in Java because someone says, new object sub 2, before their lambda, because they have to capture it for out variables and they stuff it into an object array. So, or am I the only person who's seen that?
The new object was an out array as a return to return multiple values. I try very hard not to do that.
Yeah, but sometimes you don't have a choice.
Mostly I'm able to not do that. I usually have a Boolean test that's new or not, or I have an input which I'm consuming and has leftover array bits that I can then stuff the output into.
Okay, so I mean, same difference.
It's once in a blue moon that I make a custom new that's there to do
yeah. So you have it capture an object that has some extra fields that you stuck in there for the return values. Yep.
Yes. Yes.
Yeah. But I mean, in a sense, it's the same thing.
It is.
You're working around the compiler.
Yeah. Right. Around the language. Yeah. That's a multi-return issue, though. It's separate from the notion of capture or not capture.
Right, and it's that the effects from within the lambda also can affect, like in the case here, if someone calls one of those functions while I'm in the for loop, it could cause the for loop to execute a different number of times, a smaller or even larger number of times.
Totally. You are modifying the actual I in that case.
Yeah, which is obviously horrible, so don't do that. But
in my case, a similar behavior happens. You're modifying the actual I.
Okay, that was what I was asking.
Yeah.
Because at the end of this loop, presumably I is always going to be 100. So if you call any of these functions, you always get 100 for the value of I, right? If it's captured by reference.
Sorry, I had an airplane fly overhead. I just now can hear again.
So at the end of this for loop that Cameron posted, the value of I is always going to be 100. So if you capture it by reference, you're always going to get 100 for the value of I if you call any of these functions after the for loop.
No, you call a read-write function, it's going to increment I.
Yeah, but the value of I will be 100 because you're calling it
more.
Not after you call read-write. If I call a read-write function of 10.
Yeah, okay. I see what you mean. Yeah. But the point is, right, if you're on the 0 iteration, it's not gonna, for that lambda that you create, for that capture you create for the closure, it's not the value of I inside there is not going to be 0. It's going to be 100 if you call it after the loop.
Yeah. Yeah.
It's the same as what C# does, and Java gets around this by saying you can only capture final things.
Right.
So it dodges this problem. But I've ran into this problem in C# where you're doing something like this, and then at the end of the loop, all your closures have the same value of I, which is the last loop iteration.
Right.
So you have to manually create a copy inside the loop body.
I'm sorry. My example, I'm saying count equals I. That's my manual copy.
Yeah, okay.
And in Cameron's example, he doesn't make a copy. in count. He just uses it at that time. So when that function executes, I will be 100, and he'll add it to n and do what he does.
Yeah, so a call to any of the read-write functions will change the functions, all the read-only functions as well.
Yeah, because they're all referring to some allocated, memory allocated storage location holding a value for I. You have a memory cell somewhere.
Either a register in the frame or it's been lifted.
Right, it's the optimizer's job to do what he does, and it lands where the optimizer put it. But you have a stateful thing that's called I that you can read and write. Yeah, I think we're on the same page. I don't have pretty examples lying around that I can cut and paste into the Slack channel. I'm looking at your, either you write really fast or you cut and paste something reasonable really quick. I don't have them lying around yet.
Wait, there's a Slack channel?
I'm sorry, chat channel. I intended to start a Slack channel because it's better for writing code in. Fucking Slack will let you do triple backtick and things like that, and you can get code samples in Slack that are nicer.
I whip them up in an editor and I use IDEA and then paste them in here.
Okay, but you have an editor set up to go with examples lying around. I guess I should do too.
No, I just type fast. That's
right.
why I don't. That's why I don't need a terse language like you.
All right, I claim I type fast too when I know what the hell I'm typing, and I'm still figuring out what I'm typing here.
He types loud.
I like my clacky keyboard. Because I often have missed fingers that silent keyboards don't register correctly when I'm going fast.
I always use the blue switches for everything now.
Okay.
Those are the clickety.
Yeah. I have a Cherry mechanical keyboard. And, you know, typing code used to be 60 words per minute was sort of the norm for me. It's pretty fast. A little slower these days.
That's because his variable names have one letter.
Absolutely. Oh, I'm not clicked in there. That was the what you heard for the clicks was sort of the standard medium speed when I'm going at code thing. It's all good. Coroutines. Okay, fine.
What are you reading?
I'm looking at Slack and deciding it's been an hour and 50 minutes and maybe it's time to call it and go again next week. It's kind of been fun go around here. I'm rolling backwards to see that the placeholder one is a good one. I'll have to stare at placeholders for closures. And I'm not ready for doing switches yet. Pattern matching needs a serious thinking through in my language. So I'm looking for stuff for me to go talk about or bring up or whatever. And then of course I have my 10 different tabs I gotta go stare at. All right, I'm gonna declare victory. Till we meet again?
Yeah, see you next week.
See you next week.
Thank you, bye.
Bye-bye.